Recording. So this is just kind of the introductory chapter on statistics. Does anyone know what statistics is? Anyone?
Data.
Data. Okay. Data is part of statistics, but anyone? What about data? What do you do with data?
Use it
Get
for
more data.
something.
Yeah, you use it to kind of analyze stuff, So you collect data, you look at it graphically, and you study it, and you see patterns in the data, and you try to make inferences about things from the data. Okay, so statistics is I'm going to change colors. The science of data. Okay. Science. Can you read my writing? I'm not the neatest writer on the block. That's okay. Any areas where you might use statistics?
Stock market.
Very good. Okay, so just some places where you might use it. All kinds of professions. Stock market. Any others? Sports. Yeah, baseball. That's like. Any guys read that book, Moneyball? The guy who brought that team out of nowhere. Was it the Oakland A's or something? Yeah, Oakland A's. Brad Pitt, yeah. And he was like, the guy was, I didn't never finish the book, I couldn't get that into it. But there's a movie, yeah, for those less gifted readers. I should watch the movie, yeah. And my wife would watch it if it's got Brad Pitt in it, So in any case, stock market, sports. I was just talking to a good friend of mine last night, and he works for a geological engineering company. He has a degree from mines, and he says what they do is he travels all over the country doing water testing, and they test all kinds of water for different companies to see if the companies are polluting and do they meet the requirements for the EPA and all that kind of stuff. And some companies, they produce waste, so is the company producing too much waste? So they take a lot of statistical samples and they use all kinds of statistics to compute, are they within the bounds of the, environment and all that kind of stuff. So he's kind of got a hard job because the EPA, on one side he has to appease them, and on the other side he has to appease the people who are producing chemicals and stuff like that. So it sounded like an interesting job. That's what he does. What else? Have you guys heard of data mining? This is not like mining. That's not what they do at the School of Mines. Do you guys know what that is? I have another neighbor. He works for one of these companies, and they're a data mining company. Anyone ever hear of like Google, So that's what they do, right? You log in, they get your information, and then various companies, I don't know if Google does this or not, but they buy data and to see or Amazon and stuff like that, they buy data from different companies to say, oh, this guy bought this iPod, or he's really into this kind of car, let's market it. So there's all kinds of companies whole companies that deal with marketing and data and all that kind of stuff. So there's lots of applications of statistics. One more that they had in the book is a couple more census, when they're just looking at populations, astronomers when they're looking at planetary stuff. And atmosphere, astronomers and stuff like that. So there's all kinds of places that you use statistics, okay? When you have a set of statistics, you have a list of stuff. So the other day we did, you guys did a little survey for me. Remember you filled out that little survey, hair color, how many brothers and sisters you have, how old do you think your teacher is, which was very flattering in some cases. The one that said 60-something wasn't so flattering. But someone said 25 to 29. You get an A, whoever that person was. So anyway, but when you have a list, when you have a set of data, you have the individuals, okay? Individuals. And the individuals are the objects described, they're the objects described in the set of data, okay? Objects described in for example, and those things can be, they can be people, they could be things, they could be animals. You know, maybe you're doing like a population survey on some endangered species or something like that. You're trying to figure out, you know, things about these various. They could be any types of things. So when we did our set of data, when I collected that sheet from you, what were the individuals? What were the individuals? What was I looking at? What?
Questions?
The individuals weren't the questions. The individuals were you guys, okay? The individuals were the people, the students, high school students in Mr. Reader's stats class. Those were the individuals. That was the data that I was taking, okay? And then you have the variables, okay? And the variables are just the different things that you're looking at, okay? Like any kind of characteristic. Yes, Sam.
So that would be like, for example, if you're doing like a population, a variable would be population.
Yeah. Yeah, if the individuals were, say, cities in Colorado, then a variable could be population, okay? Variable could be average daily temperature, okay? Okay, something like that. So in our survey, we talked about the individuals being students in Mr. Leader's class. What were some of the variables?
Question.
Do you guys remember? So what were some of the questions?
Like height, maybe?
Yeah, like, so in our thing, it was, in our little survey, there was height, there was eye color. Was there eye color?
Yeah.
Yeah, eye color. What else was there? Did you have your birth date in there or something? Birthday. Birthday is another one. Birth dates, eye color, height. I probably didn't ask your weight, did I? In there. Number of siblings. So those are all types of variables. Now, when you have variables, you have two types of variables. You have categorical variables. Let's change colors. Categorical. And then you have quantitative variables. Categorical, quantitative. So categorical variables put individuals into a category. Okay, so puts individuals, indivs. Did I put that? Individuals into categories. For example, hair color, right? Hair color. What else could put you into a category? Height. That's quantitative. Yeah. So you could have your birthday. Birthday, even though it's a number, is still a categorical variable, because because it's not really something that would make sense to take an average of.
Is
Or
height not
height.
categorical because there's so many?
Exactly,
different-
okay? So quantitative are things that make sense to take an average. Makes sense to find an average. So some of those over here would be height, right? Height. What's another category? Can you see that? You want me to raise it up? There we go. What's another one?
Siblings.
Siblings. What's a number that's categorical, but is not? What's a number that could be categorical, but is not a quantitative variable? Anyone think of? What? Zero? No, I don't mean a number. But what kind of? Can you think of like a variable that would be a number, but would be categorical and not quantitative? It wouldn't make sense to do an average. What are you going to say? What?
Shoe size?
Yeah, shoe size, you could kind of, if you were working at shoe store, you kind of take the average and say, okay, what do you want to say there? What?
What about maybe like girls and guys?
That's a categorical variable, but that's not like a number one. Male, female, right? Gender, call that, right? Gender would be a categorical variable. But how about a number that's also a categorical variable? They always use the example of evens and they always use like the example of zip code, right? Zip code like 80027 or something, right? It doesn't really tell you, like it wouldn't make sense to take an average of all these people's zip codes, to find out where the middle is, right? Or something like that. So zip codes, anyone think of something else like that? What else? Zip code. Come on, think. Not that early. I gotta make little pick on me cards.
Maybe like the starting like 3 digits of your phone numbers.
Yeah, the phone numbers and stuff like that. Very good. Okay, so that's the difference between categorical, quantitative, height, siblings. Can anyone think of another quantitative variable? Easy? Weight, GPA, all that kind of stuff. Okay, thank you. So then I have, we're almost done here, believe it or not. I could pause for a second. Pause. Recording this again. Here we have data, individuals, and variables, and census at a school is an international project that collects data about primary and secondary school students from Australia, Canada, New Zealand, and the United Kingdom have taken part in the project. Data from the surveys are available at the project's website. We use the site's random data selector to choose 10 Canadian students who completed the survey in each recent year. The table below shows the data. Who are the individuals in the data? What?
Province?
Not the province. No, it's not always the thing in the first column. What are we?
The people.
The 10 Canadian students.
Yeah, the 10 Canadian students that were randomly selected. Okay, so those are the individuals. 10 Canadian students who completed the survey. Okay, and what are the variables? Go ahead, Julie. Give me one variable.
The province.
Province is a variable. Is that a categorical or quantitative? Categorical or quantitative? Categorical. Quantitative or categorical?
Quantitative.
Quantitative. How many languages do you speak? Okay. It appears that all of the numbers are quantitative, right? Because risk circumference, that's something I could take the average of and stuff like that. Okay. what variables were measured, identify a candidate who would describe the individual in the highlighted row. What does this represent? Pretty easy. What? It says Ontario, male, 3, left, 150, 100, internet chat, and 10. Where did this individual live?
Ontario.
What sex is this individual? How many languages does he speak? 3, so on and so forth. That's all there is. Is that hard? Okay. So then the last little item that that we want to talk about. I was going to do this little activity, but we don't have time, and maybe we'll do it on block day anyway. So that's more of an activity day. So I'm going to go back here and talk about inference. Okay, and I already talked about inference a little bit from before. And inference is just drawing conclusions from data. Okay? So looking back at, maybe we'll just look at this thing. Okay? Out of this group of students, if you were to say about how many languages do students in Canada speak on the average? About.
Like 4, 3.
Yeah, 3 or 4, something like that. Or you can draw a conclusion. Okay? What can you say about handedness? Most people lefties or righties? Looks like most people are right. So that's just drawing a conclusion. And then all of statistics is about using tests and using bell curves and using different techniques to figure out when you can reliably make inferences about stuff. Like, is it within so many standard deviations, which we'll talk about in the next chapter. And the whole last chapters 8, 9, 10 is all about inference and figuring out when you're allowed to make a valid conclusion based on that. Okay? That's all she wrote. We're going to do an activity. But we're not. So in any case, I have some homework for you. It's really easy. It's page, do you have any questions about this stuff? Page 7. Really? It'll take you 10 minutes. 1, 3, 5, 7, and 8. And that's about all she wrote, I think. And you could get started, and you could be done by the end of the period, I would guess. Okay?
2, 5, 7.
Mark me absent.
I should really not mark you absent.
Please.
Then I have